Good day once again, learners. Your presenter is Mrs. L.A. Palazzi. Today we are going to do equivalent forms of functions and relationships. By the end of the lesson, you should know and be able to determine, interpret and justify equivalence of different descriptions of the same relationships or rule represented verbally in flow diagrams, tables, by formulae or by number sentences. Now, activity under our introduction. In a grade 7 mathematics conference, learners are divided into 10 groups. Each group has 15 learners to observe COVID-19 rules. Let us find the relationship between the number of groups and the number of learners using the number sentences. Remember, I've said that the learners were divided into 10 groups. In each group, there were 15 learners because of COVID. Now, we want to find the relationship between number of groups and the number of learners using number sentence. In group 1, there are 1 multiplied by 15 learners, which equals to 15 learners. In group number 2, there are 2 multiplied by 15 learners. We will then be having 30 learners. In group number 3, there are 3 multiplied by 15 learners. We will then be having 45 learners. Then in group number 4, then that is where we are going to find the number sentence. It's the same as the first 3 answers. We will be having 4 multiplied by 15, which equals 60 learners. And then in group number 5, there are 3 multiplied by 15 learners. We'll then be having 75 learners. Now, then in 6 groups, there are 6 multiplied by 15 learners, which equals to 90 learners. Then in 7 groups, we'll be having 7 multiplied by 15, which equals 105 learners. Now, here are the expected numbers represented in number sentences. 1 multiplied by 15 equals 15. 2 multiplied by 15 equals to 30. 3 multiplied by 15 equals to 45. 4 multiplied by 15 equals to 60. 5 multiplied by 15 equals to 75. And so on. Take note that number sentences are also used to represent the relationship between the input and the output values. Now, activity number 1. Looking at the previous activity, you are supposed to answer the following questions. From the previous activity, list the input and the output values. When you look at the previous, this is the previous activity on our introduction. We are having 1 times 15 equals 15, 2 times 15 equals 30, 3 times 15 equals 45. Then from that activity, you are supposed to list the input values. Now, when you look at that activity, here are our input values. For input values, we have 1, 2, 3, 4, 5. It is from this activity. We have 1, 2, 3, 4, 5. And the output values are 15, 30, 45, 60, and 75, and so on. Now, the second question: what is the rule in weights for determining the output values? The number of groups multiplied by 15 equals to the number of learners in a group. That is our rule described in weights. The number of groups multiplied by 15 equals to the number of learners in a group. This can be represented by n, which represents the number of groups, multiplied by 15, which equals L, the number of learners in a group. Now, activity number 2, showing a relationship between numbers in a flow diagram and a table. Before you can do that, you have to complete the flow diagram below, or the flow diagram that you see, by finding the output values. Now, remember in the previous lesson I said to you, to find the output values, it's better for you to have a number sentence. It's better for you to firstly have a number sentence. Then our first number sentence will be 1 multiplied by 15 equals the value of y, and then 2 multiplied by 15 equals the unknown value of y, and then 3 multiplied by 15 also equals unknown value of y, 4 multiplied by 15, and then the last one will be 5 multiplied by 15. Now, remember I said to you we have to write the number sentences. Before we can find the relationship or show the relationship between the flow diagram and tables, we have to firstly find the output values. Remember from the previous activities, we found that 1 multiplied by 15, the answer is 15. 2 multiplied by 15, which is the same as 15 plus 15, then equals to 30. Then 3 multiplied by 15, which is the same as 15 plus 15 plus 15, which equals to 40 in a table. Then we firstly have to fill in the two diagrams. The second diagram that we have to fill is a table. Now, remember in a table, we are having the number of learners multiplied by 15 equals to the number of groups, multiplied by 15 equals the number of learners. Therefore, we are having 1 multiplied by 15 as well. We are also going to have the same outcomes as the first one. Then we are having 1 multiplied by 15, which is 15. 2 multiplied by 15, the answer will be 30. This is for the second diagram. Now, 3 multiplied by 15 equals 45, and then 4 multiplied by 15 equals 60, and then 5 multiplied by 15 equals 75. Now that we have found the values of the output values from the flow diagram and the output values from the table, now then we are going to show the relationship between the numbers in a table and the flow diagram. Now, the third question says, what do you observe on your answers in 2.1 and 2.2? Remember, we worked out the output values of the flow diagram, and then we worked out the output values on a table. Now, what do you observe on your answers? These are our answers. The first is a flow diagram having the output values as we have calculated them, and the second is a table having the output values as we have also calculated them. Now, the observation. The rules in question 2.1 and 2.2 produce the same output values for the same input values. Therefore, the rules are equivalent. It means that if the rule in a flow diagram produces the same output values, remember the output values are 15, 30, 45, and 60. Same applies to the output values in a table. Produce the same output value for the same input values. The input values are 1, 2, 3, 4, 5, 6, 7. We can add up to 10 input values. Then if the answers are the same, if the rule produces the same output value for the same input value, therefore those two rules are equivalent, meaning that those two rules are having the same value. Remember, a rule is the relationship between a set of input values and a set of output values. Now, activity number 3, showing a relationship between numbers in a flow diagram and a table. Describing them verbally in words with a formula and or a number sentence. Now you are given a flow diagram A and B, and you are also given a table in question 3.2. Now before you can describe you can show the relationship between the two diagrams, flow diagrams and a table, you firstly have to find the values of the missing input and output values. Now let's look at diagram number A. Diagram number A, we firstly have to write the number sentence. Remember, I said that for you to be able to work out the input or the output values, you firstly have to write a number sentence. 1 multiplied by 2 from the first diagram, 1 multiplied by 2 plus 2 equals the unknown value of y. Then we have unknown input multiplied by 2 plus 2 equals 6. And then we also have 3 multiplied by 2 plus 2 equals unknown value. Then we also have 4 multiplied by 2 plus 2 equals the unknown value. Now, let's work out the output and the input values of the first diagram. Then 1 multiplied by 2, 1 multiplied by 2 equals plus 2. Then we don't know what is the value of output value. Then 1 multiplied by 2 is 2 plus 2. The answer will be 4. Then this is number 1. Then number 2, we have the unknown input value. Remember, I said that to find the unknown input value, now you are going to apply the reverse. You are going to reverse mathematical operations. Now we are going to have 6 minus 2 divide by 2. Then we'll be able to find the input value. Then 6 minus 2 equals 6 minus 2. Remember, we have to divide first. We are going to say 6 minus 2 divided by 2 equals 1. Then the answer will be 5. Then we are having number 3, which is 3 multiplied by 2 plus 2, the answer will be 3 times 2 is 6 plus 2, the answer is 8. Then here we having 4 multiplied by 2 plus 2, 4 times 2 is 8 plus 2, the answer is 10. Now, let's go back to number 2. Let's go back to number 2. Number 2, then we have to reverse. It's going to be, this is our number 2. You're going to have 6. Then instead of addition, we have to subtract 2. Then instead of multiplying, we are dividing by 2. Then we'll be having 6 minus 2 is 4, divide by 2, then the answer will be 2. Now let's check the second diagram. On the second diagram, we are having 1 plus 1 multiplied by 2, and then 2 plus 1 multiplied by 2, and then lastly we have the unknown input value. We have 3 plus 1 multiplied by 2. Then we'll be having, let's work them out and see. The last one we have unknown value of input plus 1 multiplied by 2 equals 10. Now let's check. Then the first one is 1 plus 1 is equals to 2 plus 2, then equals to 4. The second one is 2 plus 1, which is equals to 2 multiplied by 2 equals 6. And the third one is 3 plus 1 is 4 multiplied by 2, which is 8. Then lastly, we'll be having 10 divided by 2, which is 5. 5, then minus 1, the answer will be 4. Let's check our outcomes. Then for flow diagram number A and flow diagram number B, we are having the same input values for the same output values. And then for 3.2 as well, which is our table, we'll be having the same input values for the same output values. Therefore, when you look at all those 3 diagrams, we have to give our observation on them. Now, using the 3 diagrams, you have to answer these questions. Are the rules above equivalent? Give reason for your answer. Write number sentences for question A and B. Let the input value be equal to X and the output value be equal to 6. 3.5. What is the value of X in each of the number sentences in question 3.4 above? Are the number sentences equivalent? Give reason for your answer. Now, for number 1, are the rules above equivalent? When you look at these answers, you will see that we are having the same input values and the output values are the same, but the rules are not the same. Now, yes, they are equivalent because they produce the same output values for the same input values. Now, when you look at the 3 diagrams, the input values are the same and the output values are the same, but we have different rules. Therefore, both the 3 rules are equivalent because they produce the same output values for the same input values. Now, write number sentences for question A and B. Let the input value be equal to x and the output value be equal to 6. Now, for diagram number A, flow diagram A, the number sentence will be 2 multiplied by x plus 2 equals 6. And then here is our diagram. The first diagram, we are talking about the first diagram and the second diagram. That is when we are supposed to write the number sentences. Now, for the first flow diagram, 2 multiplied by x plus 2 equals 6. The second diagram will be in brackets x plus 1, close bracket, multiplied by 2 equals 6. Now, 3.5. What is the value of x in each of the number sentences in question 3.4 above? The value of x is 2. How did we get 2? We got 2, we check our number sentence. Let's take the first number sentence to check how did we say the x value there is 2. Then number sentence number 1, it says 2 multiplied by x plus 2 then equals 6. Let's do the first one. I just want to show you the first one only. We are going to have 2x plus 2 equals 6. I want to show you where does 2 come from. Then we are having 2x equals 6. Remember, we are adding with this 2 here. And then when it comes to the right-hand side, we are going to subtract. Then we are having 2x equals 6 minus 2 is 4. Then we have to find the value of x. Therefore, we have to make the denominators the same. We are going to divide with the same denominator as the above. Then we are going to say 2 goes once in here. Then we are left with x. Then in 4, how many 2's in 4? There are 2. That is where we found the value of our x. Now, 3.6. Are these number sentences equivalent? Let's check number B, whether we will be having the same value of x before we can go to 3.6. Then we are having x plus 1 multiplied by 2 equals 6. Then we have to work that out. Then we are having x plus 1 times 2 is 2 equals 6. Then x equals 6. 2 here we were adding, but when it comes to this side, we have to subtract. Then it's x equals 6 minus 2, therefore, sorry for that. Sorry for that. Let's do it again. Let's check our. It says x plus 1, close bracket, multiplied by 2. Then equals 6. Now I can see where I have made a mistake. Instead of multiplying, I have added. Instead of multiplying, I have added. Now, instead of multiplying, I have added. Now, let's do it this way. It's going to be x plus 1 multiplied by 2 equals 6. Then we are going to have x, remember x plus 1 is the same as x, multiplied by 2 equals 6. Instead of multiplying here, I have added. Then we are having 2x equals 6 divided by 2. Then the value there is 3. Then let's check whether the rules are the same. Now it says the value of x is 2. For us to find it simpler, let's substitute. Where it's 2 is x, you put 2. Now to check, let's check. Where is 6, you put 2. We are going to have 2 multiplied by x plus 2 equals 6, which is the first one. Remember we said our x value is equals to 2. And then number b, sorry for that confusion. Number b is x plus 1 multiplied by 2 equals 6. Now for the value of, we have to substitute. Where is x is 2 multiplied by 2 plus 2, then we must get 6. Then is 2 times 2 is 4 plus 2, it gives us 6. Therefore, that value is correct because we got 6. Then now, the second one, we are going to substitute. Where it is x, we are going to put 2. Then we are going to start with the bracket. You are going to say 2 plus 1 is 3, then multiplied by 2 equals 6. Now, the value of x in both of the two equations will be 2. The value of x in both equations will be 2. Number 3.6, are these number sentence equivalent? Yes, they are equivalent because in each case, the output value is 6 if the input value is 2. Then remember that, how did we come to this conclusion? We took the value of x, which is 2, and substituted, that is the correct way, substituted into our the number sentences in 3.4. Now, activity number 4. For activity number 4, we'll be having the table. The question says, we are going to show a relationship between numbers in tables, describing it verbally with a formula and or a table. We are given the input value and the rule. Use the rule to complete the table. Now, the second one, write a number sentence to find the value of x if the output value is 22. Number 3.3, draw up a table to check whether the rule in this flow diagram is equivalent to the rule in question 3.1. Now let's work out the first one. Let's work out the first one. The x values are 1, 2, 3, and 10. Then the rule is y equals to quarter x. Now, we are having the value of, we are going to substitute with 1, 2, 3, 10 in place of x. Then the first one, we are having a quarter multiplied by 1, then the answer will be a quarter. Remember, any number multiplied by 1, the answer will be that number. Then number 2, we're having a quarter multiplied by 2, which equals a quarter multiplied by 2 out of 1, which equals 1 multiplied by 2 will be 2, 4 multiplied by 1 will be 4. Therefore, the answer here will be half in its simplest form. Then let's take 3. Y equals a quarter multiplied by 3. Then we don't have denominator, then we have to put 1 equals 3 quarters will be our answer. These are our output values. Then number D, y equals quarter multiplied by 10. We don't have denominator, therefore we have to put 1. Then we have 1 multiplied by 10 is 10. Then out of 4 multiplied by 1, which is 4. Now, we have to simplify this. How many 4s into 10? Then we're having 2 4s. Now, how much is left if we are having 2? If we are having 2 4s, we are left with 2. We are going to put it here. Then into 20, we are left with 2, sorry. We are left with 2, only 2. Is 10. We are left with 2. We have to put it here. Sorry for confusion. We are going to put it here. Now, 4 into 10 goes 2 times. The remainder will be 2, and then we'll be having our denominator 4, which is 2 quarters. In its simplest form, we are going to have 2 and 1 half. Now, let's check the rest. Our answers will be like this. The first one, we have done it with you. We find that the values of y are in a table are quarter. 2 quarters in its simplest form is half, where the input value is 2. Where the input value is 3, then the output value is 3 quarters. Where the input value is 10, then the output value is 2 and a half. Now, the tables are complete. Now, the next question was, draw up a table to check if the rule that is given is equivalent to the rule in question 3.1. The question 3.1 is a diagram with the rule, is a table with a rule y equals a quarter x. Now, when you look at the table that we have drawn for 3.3, check then the rule. The rule is y equals x multiplied by 6 multiplied by a quarter. Now, when we work out all those, we found that the value of 1, where the input value is 1, the output value is 1.5. Where the input value is 2, the output value is 3. Where the input value is 3, the output value will be 4.5. Now, when you look at those two outcomes, what will be your observation? Now, let's check. Here is a number sentence for the first diagram. A quarter x equals 22. Remember, the question was, write a number sentence to find the value of x if the output value is 22. Then a quarter x equals 22 will be our number sentence. Now, there is a table that is drawn with the output values. Now, when you look at the two tables, do you see the similarities in the answers? Do you have the same output values? That's the first question that you have to ask yourself. We are having the same input values, but now, do we have the same output values? When you look at them, the answer will be no. Then, this will be our observation. The two rules are not equivalent because they do not produce the same output values for the same input values. The two rules are not equivalent because they do not produce the same output values for the same input values. That is the observation. Remember, previously we said that if the rules are equivalent, if the rules have the same value, those rules must produce the same output values for the same input values. In this instance, the two diagrams have the same input value, but they have different input values, meaning the two rules, y equals a quarter x and y equals x multiplied by 6 multiplied by a quarter, they are not equivalent because they do not produce the same output values for the same input values. Now, let's look at the next activity. We are going to show the relationship between numbers in a table, describing it with a number sentence. Now, we are going to work out the answers. The first question says, write down the rules in the table that are equivalent. To find out if the rules are equivalent, we firstly have to work out the answers. We firstly have to work out the answers. Now, number 2 says, write number sentences for all the rules if the input number is 30. And then the next one says, write down the values of x in the number sentence in the number sentences that are equivalent. Write down the values of x in the number sentences that are equivalent. Which number sentences are equivalent? Here are our outcomes. After doing some calculations, we will realize that 3 multiplied by x plus 2 multiplied by x. If the input value is half, when you substitute 3x in the first rule, you will find that if the input value is half, then the output value will be 5 out of 2. Let's do the calculation to check how we got the first one so that we can be able to continue with the next answers. Is 3x rather 3 multiplied by x plus 2 multiplied by x. I'm only going to take the first row. And then the second one is 5. Remember, the output value there is half. The input value rather is half. Then 5 multiplied by x. Then we want to know what is the value of that, of the output value. Then lastly we have 4 multiplied by x plus x. Now, then the first one, remember we are going to substitute is 3x equals 3 multiplied by x plus 2 multiplied by x. Then we are having 3 multiplied by a half plus 2 multiplied by a half. Then is 3 halves plus 2 halves. Then our answer, because we are having the same denominator, then we take one denominator and add the numerators. Is 3 plus 2 equals 5. Then in its simpler form will be 2 and a half. Then let's take 5 multiplied by x. Then we'll be having 5 multiplied by a half, which equals 5 multiplied by 1 is equal to 5, then half. 5 halves. Then the 5 halves equals to 2 and a half. Then let's take the last one. It is equals to, it's 4 multiplied by a half plus a half. Then we'll be having 4 multiplied by, remember we don't have numerator there, we can put 1. 4 denominator, we can put 1 rather. 4 multiplied by 1 is 4 halves plus 1 half. The value will be 4, because we are having the same denominator, then we take 1 and add the numerator. It's 4 plus 1 equals 5. Then in its simplest form is 2 and a half. Now let's go back to our answers. Now, I have shown you how we have come to a conclusion that when you substitute the half as the value of x, then you get those answers. Now, we are going to answer number 1. Write down the rules in the table that are equivalent to each other. When you look at all the output values that we have from the input values, they are all of the same value. Then this will be our conclusion. All the rules are equivalent to each other. They produce the same output values for the same input values. Even though we did only the first one, we have realized that all the rules are giving us the same answers, even though they are not the same. They are not the same. But because the input values are the same, therefore the output values are the same, therefore the 3 rules are equivalent. Here are the number sentences. For the first one, the number sentence, it says you write the number sentence for all those rules if the output value is 30 or the output number is 30. Then the first one will be 3 multiplied by x plus 2 multiplied by x equals 30. The second number sentence will be 5 multiplied by x equals 30. 5 multiplied by x equals 30. Number 3, 4 multiplied by x plus x equals 30. Those are the number sentences if the output number is 30. Now, write down the value of x in the number in the number sentences that are equivalent. The value of x will be 6. Now, let's check if 6 is the correct answer. Now, how are we going to do that? We are going to substitute where there is x, we are going to substitute that x with the number 6. That all in all, we must get 6. Then number 1, we have 3 multiplied by x plus 2 multiplied by x. Remember they said the output value there is 30. Then let's take number 2. It says 5 multiplied by x equals 30. And then number 3, it says 4 multiplied by x plus x equals 30. Now, remember we said the value of x is 6. We want to check if that is correct. Now, we have to check that is correct, if that is correct. We are going to have 3 multiplied by 6 and then plus 2 multiplied by 6. These 2 must give us 30 to make that value of x correct. Then 3 multiplied by 6 equals 18 plus 2 multiplied by 6 equals 12. Then 18 plus 12 equals 30. Therefore, for the first rule, 6 is correct. Now, let's go to the second rule. 5 multiplied by x is 5 multiplied by 6. Then 5 multiplied by 6 equals 30. Therefore, the second rule, the value of x, if we substitute 6, x with 6, then we get 30. Then 5 multiplied by 6 equals 30. Let's take the last one. It's 4 multiplied by 6 plus 6. It must give us 30. Then 4 multiplied by 6 is 24. Then plus 4 multiplied by 6 gives us 24 plus 6, then it will be 30. Therefore, that value of x is correct. Which number sentences are equivalent? We have come to a conclusion that all the number sentences are equivalent because for the input values, the same input values, we got the same input value. The input value there is 6, and then the output value is 30. Therefore, in all those 3 number sentences, we have the same input value, which is 6, and the same output value, which is 30. Therefore, all the number sentences are equivalent. Now, I have come to the end of my presentation. Before that, I would like to wrap up saying that, giving this to you, saying that the rules are equivalent if they produce the same output values for the same input values. The input and output values can be represented in different equivalent forms, which are verbal descriptions, number sentences, flow diagrams, tables, and formulae. Number sentences are equivalent if they are written from equivalent rules and therefore have equal input values. Thank you very much. Thank you for lending me your ears for these past few minutes. Enjoy the rest of your day. Thank you.